In this 3D model, you can see the first component of the gas absorption heat pump, the evaporator. In here, the temperature is below the freezing point. Quite cold. Now you're probably wondering, how can something evaporate at such low temperatures? There is usable heat energy in our environment even at sub-zero temperatures. The transfer takes place through the initially liquid refrigerant, which absorbs the heat from the environment and becomes gaseous. See for yourself. Here you can see how the refrigerant in the test tube evaporates already at -30 degrees. Although it is this cold here, at this point the energy of the environment is transferred to the refrigerant. And already we have gained 30% of the energy we need for our heating circuit from the environment for free. Let's have another look at our model of the gas absorption heat pump. In a second step, our gaseous refrigerant enters the absorber. Inside there's water. Water absorbs the refrigerant. This means it mixes. In our case, water combines with the gaseous refrigerant and reacts. During this process, energy is released. A look at the thermal imaging camera shows how the temperature rises. In the heat pump model, we see how a pump transfers this mixture to the generator. In the generator, a gas burner is now heating up the mixture. This adds more heat energy to reach the temperature needed for the heating system. This causes the substances to separate again. The water remains liquid, but the refrigerant becomes gaseous. The separated water is then returned to the absorber. In the condenser, the gaseous refrigerant releases its energy to the system in the form of heat. In the process, the refrigerant liquefies again and is returned to the beginning of the cycle. In our glass spiral, we see the gaseous refrigerant flowing into the upper third. It then cools down in the middle section. Drops form, which finally collect again as refrigerant liquid, and thus the cycle closes. Let's have a look at the interaction of all the individual steps. In our 3D model, you can now see all functions of the absorption circuit. This technology is absolutely reliable, wear-free, and with an efficiency of over 130%. Highly efficient. So, what does the gas absorption heat pump technology bring us? Easy energetic modernization of 85 million existing buildings across Europe. High flexibility for any heating situation and thus maximum comfort. The use of 30% renewable energy, saving us money and protecting the environment. A lot more information on the advantages of gas absorption technology, such as minimal noise, sustainability, and comparisons with other technologies, can be found on our website, theheatingsolution.com. I have presented you an innovative technology which is an ideal heating system for renovations.